Okay, so welcome back to another video. This one is going to focus around fullerenes, and I'm also going to touch on carbon nanotubes. Okay, so last time you probably looked at giant covalent structures. Now fullerenes are, I guess, a kind of similar molecule but also different. So fullerenes are also carbon allotropes. Again, remember, allotropes meaning that they're made of carbon but they have different structural forms. Basic definition question that they could ask you what is an allotrope. Okay, so make sure you are ready to answer. Now, usually fullerenes will form two things. They'll either be hollow tubes or they will be spheres. Okay, and generally they will be one of the two things. So hollow tubes or spheres. That's really important because it's really important for their properties. It gives rise to a lot of their properties. Okay. Now, the first fullerene that I'm going to choose to look at, and probably the one that you'll recognise the most and you'll have the most focus on, is going to be a molecule called buckminsterfullerene. Okay, and buckminsterfullerene, yes, and actually I've just realised I've spelt it wrong. It's buckminsterfullerene. Buckminsterfullerene is classically, it's the football-shaped molecule. Okay, sometimes the Americans might call it the soccer ball molecule, but it's a football-shaped molecule. Now, that means it's spherical, but it also means, and this is important here because you can be asked about this, it means that it's made up of two shapes. It's made up of hexagons and it's made up of pentagons. Okay, so buckminsterfullerene is made up of pentagons and hexagons. It is spherical, right? Now I cannot draw a 3D sphere here, but it's spherical. Really important here. Spherical, yes. Circular, no. Okay, circular implies that it's not 3D. It is 3D, okay? It is spherical, it's hollow on the inside. Now, the hollow bit of it is really important, okay? Because fullerenes have, or buckminsterfullerene specifically, has lots of uses. Now, the fact that it's hollow means that it's really, really good for drug transport, so we can put drugs inside there and we can transport them to specific locations in the body. Please do not write that they are used as drugs. The fullerenes themselves are not drugs. It's the drug put inside that's transported around. They can also be used to trap catalysts in. Okay, so they're really, really useful for us in a similar way, right? We trap catalysts inside the ball, and they're used like that. And then finally, another really useful property of them is they are really good lubricants. And this one requires a little bit more thinking about to explain it. Okay, so the reason that they are such good lubricants is all to do with the fact that they are spherical. Okay, so because the molecules are spherical, they are able to roll. Okay, so because they're spherical, they can quite literally roll along like that, and they're a really good lubricant because of it. Okay, so the molecules are spherical, and that means they can roll. In a question, make sure that you are saying both bits to get the mark. Don't just say that molecules are spherical and expect the examiner to assume that means that you know they can roll. Tell them that. Okay, put both bits, get both of the marks. Actually, one final point, which is also really crucial to their uses and their usefulness, is the fact that because they've got this huge hollow sphere, they actually have a huge surface area. And again, this makes them incredibly useful for things like trapping catalysts and drug transport and stuff like that. They have massive surface areas. Right, now we also said we were going to talk about carbon nanotubes, so let's have a look at those. Now, carbon nanotubes they're made from graphene. Right, so a carbon nanotube, and I'll write up here, nanotube, is made from graphene. And essentially, it is a layer of graphene rolled into a tube. Okay, so a carbon nanotube is quite literally a tube. Okay, and it's one layer of graphene rolled up into this tube. Again, really importantly, it's hollow. Okay, absolutely make sure you know that it's hollow. It's a hollow tube, okay, but it's graphene rolled up. Imagine you're rolling a piece of paper. Now, when we talk about nano is reference to the fact that it is times 10 to the minus 9 meters. So it is tiny, really, really, really small. Okay. However, because they're so small, they are incredibly useful. Now, they're used an awful lot in special materials, electronics. Nanotechnology bases a lot around carbon nanotubes, and really it's for two properties. Nanotubes they have a very high tensile strength. Okay, in other words, they're very resistant to breaking, right? You have to put quite a lot of force into these relative to their size to break them, and that is all down to the fact that they have those strong covalent bonds. The other property that makes them incredibly useful comes from graphene, and at this point I would hope that if you've watched the other videos you might be able to pull this one out, but graphene is a very good conductor, and this makes them incredibly useful for use in electronics and specialised tech like that requires something to conduct electricity very well, whilst also being incredibly small, incredibly strong. Okay, that's probably enough on fullerenes and carbon nanotubes. The last and final video in this bonding series is going to be centred around nanotechnology.